Hello everyone. In this video we're going to practice analyzing circuits that include two-port subsystems. In this specific example we have two subsystems for one of which we have the Z parameters and for the other one we have the Y parameters. The process is exactly the same. We're going to start by identifying the nodes. And then after which we're going to name them. So this port, I'm going to call it V1 to basically go with what we have. When we write the equations, we use these currents and voltages. So I'm going to try to stay consistent so that we don't have to change much for the first system. But then since we have two systems, then for the second one I can't use the same V1 and V2, so I can use V prime 1 and V prime 2, or V1 prime and V2 prime. And for the currents I'm going to do the same, I1 prime and then I2 prime. So now if I assume this is ground, this would be VG, which is given as 30 millivolt. This turns into V1. Now if I want to name these individually, I can, but since there are no other components in the middle, I really don't have to do that. I'm just going to stick to these voltages that are defined as the difference between the two potentials. Then going here, I have V2 prime positive and V2 prime negative as the two names. Now the current that is passing through this resistor is also I1 obviously, and the current that is passing through this resistor, the load resistor, is I2 prime. Okay, now I'm going to start writing the equations. Obviously there are no KCLs, so we're going to directly move on to writing equations for components. Start with the 10 ohm. I1 is equal to 30 millivolt. So if I write everything in millivolt and resistors in ohm, then all the currents are going to be in milliamp. So 30 minus V1 divided by 10. Then I'm going to go to the other resistor and write the equation for that component. So that would be I2 prime is equal to V2 prime minus or negative minus V2 prime positive divided by 15,000. But obviously from the definition for V2 prime, we know that this is actually minus or negative V2 prime divided by 15,000. So with those two equations, we are only left to write the equation for this port and that port. So let's move on. So the equation, these two subsystems, that's what I meant. So we treat each one of these subsystems as a component, and we use the Z parameters for this one and the Y parameters for the other one as the equations for these two components. So the Z parameter equation for the subsystem on the left would be V1 is equal to Z11, which is 35 divided by 3 times I 1 plus Z12, which is minus 100 divided by 3, so that would be minus 100 divided by 3 I2, and then V2 is equal to Z21, which is 4000 divided by 3 I1 plus Z22, which is 10,000 divided by 3 I2. So those two are equations for the subsystem on the left, and then for the subsystem on the right we have the y parameters. So now I prime 1 is equal to y11, which is 200 microsiemens. So I'm using ohm, so I'm going to use also Siemens. So that would be 200 times 10 to the minus 6 V prime 2, V prime 1, I'm sorry, and then plus y12, which is 40 times 10 to the minus 6 V prime 2, V2 prime, and then I2 prime is equal to minus 800 times 10 to the minus 6 V1 prime plus 40 times 10 to the minus 6 V2 prime. Now after this, the only thing that we have to now rectify is that the definitions we have require clarification. For example, for this node that I define, I can actually write a KCL or just realize that I2 plus I1 prime is equal to 0, or in other words, they are opposite of each other. So I'm going to add that equation down here. These are not equations for components. So that would be I2 is equal to minus I1 prime. And then the same with the voltages. These, the V2 and V1 prime are the same. So V2 is equal to V1 prime. And once we finish with this, we can actually start calculating all the unknowns in the circuit. Now we can actually count all the unknowns. So we have 1, 2, 3, 4, 5, 6, 7, 8 unknowns, all the currents and voltages in the circuit. And we have 1, 2, 3, 4, 5, 6, 7, 8 equations. So that should give us exactly all the unknowns that we need. So I'm going to open up our maxima and start putting the equations in. So in an earlier video I explained how you can use maxima. I'm going to just go ahead. We're going to pick the linear equation solver, linear equation system solver, then enter the number of equations that we have. So we have a total of 8 equations. Then start entering all the equations in there. So I1 is equal to 30 minus V1 divided by 10. I2, I'm going to prime, instead of prime, I'm going to use P. So I2P is equal to minus V2P divided by 15,000, sorry. Then V1 is equal to 35 divided by 3 I1 minus 100 divided by 3 I2. For all of these I have to make sure I'm using the right, so I have to have the multiplication. Then we're gonna move on to the fourth equation. V2 is equal to 4000 divided by 3 multiplied by I1 plus 10,000 divided by 3 multiplied by I2. The fifth equation, I1p or I1 prime is equal to 200 times 10 to the power of -6 multiplied by V1 prime plus 40 times 10 to the power of -6 times V2 prime the sixth equation, I2 prime is equal to -800 times 10 to the power of -6 times V1 prime plus 40 times 10 to the power of -6 V2 times V2 prime, and then finally I2 is equal to minus I1 prime and V2 is equal to V1 prime. And we're going to ask for all the variables, so we want I1, I2, I1 prime, I2 prime, V1, V2, V1 prime, and V2 prime. And there we go. So we have all the values. I1 is 1, I2 is minus 0.25, and so on and so forth. So all the results look quite reasonable. So with this, I'm going to conclude. Hopefully this has been helpful. Thank you for your attention.